So today we're going to talk about 3D trig problems. As it says on the page, when considering a 3D trig problem, you must draw a diagram because it's all about perspective and understanding what steps you need to follow to solve the problem. Because these are always going to be a multi-step problem, so you need to know where to start and then where to go. So first example is the Great Pyramid of Cheops in Giza, Egypt. It's a square-based pyramid with sides measuring 230 meters. So right there we have a clue. It is a square-based pyramid. That means that all of the sides are equal and that I can calculate the distance to the middle of the triangle. So carrying on, it says the angle of elevation of one triangular face is 52 degrees, and that's what we've got right here. And then it says determine the measure of angle theta, which is between the height of one of the edges where the two triangles meet. Okay, so it's really hard to draw 3D. So I tried really hard to demonstrate to you where theta is. And the end of this arrow is right inside. So think of, it's trying to highlight this edge, right? This edge, and where that edge, the angle between that edge and the center of the triangle. So it's hard to draw, but that's what we're trying to find. So again, think about the information you've been given. So I know that all of my side lengths are 230. 230, 230. I know that this distance here is half of 230, or 115. So I can use that. I also know that this is 115. So I can use some of this information to start filling in some of the missing pieces. So one of the missing pieces that I can fill in is what is that length? So what is the length from the center of the floor of the pyramid to the corner? Well, that's just Pythagorean theorem. So it's 115 squared plus 115 squared. Take the square root of that to find x. So in this case, we're going to say just go ahead and use a decimal. I'm going to round to the first decimal place. So I'm going to say that this x distance here is 162.6. So now what I can do is I can use this triangle. I have this angle, because remember I don't have this angle down here, but I have this angle, and I can use that plus the 115 to find the height, the interior height of the pyramid. So I use SOHCAHTOA for that because it's a right angle triangle. So the tan of 52 is going to be the height divided by 115, or opposite over adjacent. So the height of the triangle is 147.2. So coming back to what the piece of information was that I was looking for, remember I was looking for this angle up here. Well, I now have the information that I need because I have this length and I now have this length. So once again, I can use tan to find what that angle theta is. So tan of theta is going to be 162.6 divided by 147.2. So to use the inverse tan to figure out what my angle is. So theta is 47.8 or 48 degrees. So that is, remember what I said, everything's going to be a multi-step problem, and you need to figure out what I know. How can I use what I know to figure out what I need to know, and very methodically work your way through the problem. So here's a very typical problem. From the top of a tower 68 meters tall, the angles of depression to two fires are 5 degrees and 8 degrees respectively. If the angle at ground level between the lines of sight of the two fires is 110 degrees, determine the distance between the fires. So let's unpack that a little bit. First of all, we've got a tower that's 68 meters tall. We'll draw that. Next thing you've been told is the angle of depression to two fires are 5 degrees and 8 degrees. So let's draw some fire. Okay, so we've got some fire. Got two fires. Remember now, it's angle of depression. So in order to get the angle of depression, I have to go from the horizontal down. So there's my angle of depression. Sorry, my degree sign doesn't look very nice. So then the next thing it says the angle at ground level. So this is going to be now at the base of the pole, or the tower, between the lines of sight of the two fires. So that means that the line of sight between there and there is 110 degrees. And then it says how far apart are the fires. So step 1, draw the diagram. What do we know? This is what we know. This is what we've been given. There's the tower. We know the angles of depression. Remember, if I know the angle of depression, that means that from the perspective of the fire, I know the angle of elevation to the top of the tower. And that's using my TPT's Z rule. And now I can figure out what these lengths are right here, because I'm going to need those in order to figure out how far apart these two fires are. That's what I've been asked to find. So step 1, let's work on the left-hand side of this drawing. So we're going to go with the 5-degree triangle. So we know that we're going to use tan, because we want the tan of 5 degrees is going to give me opposite, which is the height of the tower, over adjacent, which is the distance from the tower to the fire. So now I'm going to use the tan of 5 as 68 over x to figure out the distance from the fire to the tower. And 68 divided by tan of 5 is going to give me 777.2 meters. So now I'm going to use the same technique to figure out what the distance is from the second fire to the tower. So tan of 8 is 68 over y is 68 over tan 8. So the second fire is 483.8 meters from the tower. Now I can use those two things and use the cosine law to figure out what the distance is between the two fires. So now I'm going to use the cosine law to figure out the length of z. And there is the roughed in data for the cosine law for that length. Next step. So I took the 752,018.72, multiplied it by the cos of 110, added that because that's a negative, and so that becomes positive. So you add that to 838,102.28 without clearing the calculator, and then take the square root, and you get 1,046.6 meters. So therefore, the distance between the two fires is just over a kilometer, 1,046.6 meters, or 1 kilometer, 46.6 meters. So next example. So Hannah and Sid are contestants in a new reality TV show, T for Trig, Trig for Geniuses. They're tied for second place and are trying to determine the height of a solid gold statue of the pharaoh. Sid cites the angle of elevation to the top of the statue at 14 degrees. Hannah is standing 80 meters from Sid and cites the angle of elevation at 23 degrees. Determine the height of the statue if the angle between their sight lines at the base of the statue is 90 degrees. Oh, isn't that nice? We gave you a 90-degree angle at the bottom. Okay, so let's draw the diagram and put in what we know and what we don't know. There's my lovely statue of Pharaoh. So there's Sid with his angle of elevation to the top of the statue of 14 degrees, and Hannah with her angle of elevation of 23 degrees, and the angle between their lines of sight is 90 degrees, which means that the hypotenuse of this is 80. So now let's do some figuring. So remember, this one says we need to think of this as a system of equations in order to get a variable, because if you're looking at this, you say, well, I'm missing information. I don't know. So what we're going to do is we're going to label our triangles and then get thinking about how we can put this into a system. So we'll label this side opposite Hannah as H, the side opposite Sid as S. And you know that we can get those lengths by using the Pythagorean theorem, if we knew one of them. But we also know that we've got the height of Pharaoh and the distance between Sid and Pharaoh, and the height of Pharaoh and the distance between Hannah and Pharaoh. And so we can use all of these three things and put them all together and then use it as a system to solve for our unknowns. So first we'll set up a couple of equations. So now we have, with rearranging our tan of 14 and tan 23 equations for the height of Pharaoh, we can throw that into our Pythagorean theorem of 80 squared equals h squared plus s squared. And now we have all of our variables in terms of 1, so that now we can go ahead and solve for p squared. So in an effort to do as little rounding as possible, our common denominator is tan 14 squared times tan 23 squared. So we can take that tan 14 squared and tan 23 squared and multiply each term in our expression by that. So when we multiply this by tan 14 squared times tan 23 squared, of course the tan 14s cancel out, just like when we multiply this by tan 14 squared times tan 23 squared, the tan 23s cancel out, which is how we end up with p squared times tan 23 squared and p squared times tan 14 squared, and our left side being 6,400 times tan 14 squared times tan 23 squared. And so now we just have to do some math. Now at this point we are going to have to do a little bit of rounding, but I would suggest that you wait to do your rounding until you have popped into your calculator the tan of 14, square it, times the tan of 23 squared times 6,400, and then round your answer to 4 decimal places. So 6,400 times tan 24 squared times tan 23 squared is 71.6846, and tan of 23 squared is 0.1802 times p squared. Tan of 14 squared is 0.0622 times p squared. Now I'm going to collect my like terms. These are like terms. And we'll finally isolate p squared and then take the square root to get the answer for the height of our statue. So when we do that, we get that the height of our statue is 17.2 meters. And we're done.